Not only is reductionism problematic insofar as it means we're ultimately living a lie and not seeing what is really there, but there is a problem in terms of concept versus quantity and what comes prior. For it is an equivalent of the chicken versus egg scenario. The classic question of which comes first, the chicken or the egg, is ultimately the chicken. For even if the first egg existed before the first actual chicken, it is a chicken that must pre-exist, because the egg only exists for the sake of one day becoming a chicken. Thus, the concept of chicken must exist before one can create an egg. However, the reductionist claims the egg is more important than the chicken. In the reductionist view, quantity is considered most important and reality, whereas quality is secondary and a figment of our imagination. However, there is a problem. We know form before we know quantity. Or we could say, in terms of knowledge, form is prior to quantity. Man must have a knowledge of a thing in order to quantify it. To put this in Aristotelian terms, we can say that quantity is an accident that only exists in a subject. As I have stated, modern physics is attributed to the discoveries of Isaac Newton, and it is the grounds by which many people hold to the reductionist view. The many achievements that have been attained through modern physics is a sign of progress that man has been able to accomplish with his quantitative knowledge. It has made the unimaginable possible, such as landing on the moon and returning, and the ability to control a single atom in a super accelerator. To understand the defects of the purely quantitative system, we must first start with something that can be fully explained quantitatively. Even if we start with the smallest particle, we have not attained that. We tend to think of electrons, protons, and neutrons as little balls orbiting a nucleus. However, there has been great disagreement on that, for these balls are actually made up of smaller things, which are made up of smaller things. Assuming there is a smallest particle, we are still not left with pure quantity, for we have a concept, an idea. When we imagine this small particle in our head, we impose quality on it. Once we attribute extension and existence, it will naturally have accidental qualities, at least in our understanding of the small particle. As we continue in our knowledge or understanding of this small particle, we will claim it has certain accidental qualities and behaves in a certain way with other particles. To say this is to have a form or concept of this thing. Thus, the world cannot be comprehended with pure quantity, for eventually, man must refer back to some sort of form or concept. Thus, one cannot comprehend the world or the quantitative without adhering to some sort of form. Modern technology has allowed us to observe the atom at a microscopic level that was never before possible. At this extremely small level of an examination, we did not find the perfect mechanistic world, and this puzzled scientists. Albert Einstein referred to it as spooky. The traditional mechanistic paradigm was unraveled, and new theories would have to be suggested. One of the bizarre features was that though we are able to very accurately predict and calculate the probabilities for the projection of particles, they do not necessarily follow a perfect mechanized trajectory. This came to the creation of what was called Bell's theorem. This theorem basically states that the motion of subatomic particles cannot be predicted through the laws of physics. Unlike a ball that I hold in my hand, if I throw it through the laws of physics, by knowing the properties of the material in the ball and the wind speed, I can perfectly predict the trajectory of this object. However, with subatomic particles, this was not the case. Understanding the nature or the electronness of an electron was not sufficient for determining how the electron would act and respond. This means that a mechanistic view of quantity does not provide all the answers for explaining the external world. Although on a macro level, the mechanistic view of Isaac Newton was very successful, however, on a micro level, it has failed to predict the motion of subatomic particles.
In everyday life, a place where we can experience and encounter things. The macro world. Things can be produced according to the physical mechanistic explanation of Isaac Newton. However, on the micro level, at the subatomic level, things are very different. This new understanding of how things work has caused scientists to come up with new explanations of the atom. All these systems have to cope with the fact that what is perceived and known through the senses, or at the macro level, behaves mechanistically. Yet, that which is only known through instruments that are smaller than what can be sensed has a different rule for its motion and for its action. The Aristotelian would say, we know sense objects because we know their nature. It is from a knowledge of this nature that we understand how they will work and function. Though we can grasp the nature of things on the macro level and predict their motion with great certainty, we cannot appear to grasp the nature of things on the subatomic level, for these particles do not behave in accord with the way we understand their nature. The downfall of the traditional mechanistic view has led to man embracing all sorts of new theories. Though there is much attempt to restore the age-old theory of reductionism, new theories tend to try to understand the motion of these particles through looking at the atom as a whole, instead of just looking at the individual subatomic particle. This is because to predict the motion with great probability, one must have a knowledge of the entire atom, and not just a particular subatomic particle. For it would appear that motion is determined not by something intrinsic to the property of the subatomic particle, but rather by studying the entire atom, which the particle is intimately connected to. For these new views of explaining the trajectory of the subatomic particles rely on a holistic understanding of the atom. This is the beginning of acknowledging the existence of the Aristotelian concept of a substantial form. When scientists first tried to make sense of the subatomic particles, it was because their motions did not coincide with the scientists' concept of these particles that they realized there was a problem. We could say that scientists were imposing a form or nature on these subatomic particles. However, now scientists are attributing this nature or principle of motion not to something intrinsic to the subatomic particle, but to something intrinsic to the atom as a whole. This is the beginning of acknowledging the atom as not a conglomerate of parts, but of having a unit of principle that makes the atom one single thing. This is what the Thomists call a substantial form. For as was clearly stated in St. Thomas's commentary on Aristotle's Physics, it is the substantial form of an object that determines its motion. Deep within the perennial philosophy lies an alternative to the mechanism we see of Newton. It is a Thomistic and Aristotelian ontology of hyomorphism. This system claims that all material things are a composite of matter and form, and it solves many of the problems of mechanism in light of modern science. The bizarre phenomenon we see of a subatomic particle in an atom can be explained analogously by the relation to virtual substances in a human. Just as man is one substance, and things such as calcium and other materials virtually exist in him, or in other words, things appear to exist, such as calcium, but it does not actually exist as calcium because it does not have the substantial form of calcium. A similar scenario can be in an atom, for when an atom has seemingly particles in it, such as electrons, protons, and neutrons, these things do not actually exist in their own right. Rather, they exist as a part of the entire atom. Thus, while these subatomic particles are part of the atom, they do not have their own essences and natures, but rather the matter is given its very being from the essence or substantial form of the atom itself. Thus, the atom is not just a pile of subatomic particles. Rather, the atom is one thing with multiple parts. Since the subatomic particles do not have their own nature, but attain their nature or principle of motion from the substantial form of the atom, we now have an explanation for why the motion of the atom can only be understood from a comprehension of the entire atom, and not just a comprehension of the individual subatomic particle.